In this video, we'll be discussing the concept of independent and dependent events and exploring how independent and dependent events behave differently in terms of probabilities. First, we need to make sure that you have a working understanding of what independent and dependent events are. If two events are independent, that means that the results of one event have zero effect on the results of a second event. Let's give an example. If you roll a die, and then you pick up that die, and you roll the die a second time, those two events are independent. What you get on the first roll has no effect on what you get on the second roll. So that would be an example of independent events. Now, let's give an example of dependent events. Let's say, for example, that you have 5 playing cards on the table, and you draw a card, and then without putting that card back, you draw a second card. In that case, the probability of what you draw on the second draw is dependent upon what you drew on the first draw. Those two events are dependent. The results of the second part of that experiment are dependent upon what happened in the first part of the experiment. We'll talk a little bit more about this via the way of example problems. Before we do that, it's important to note this definition here, also found in your text. If A and B are independent events, then the probability that both A and B happen, which would be the same thing as saying the intersection of A and B, is the probability of A times the probability of B. And this can be extended for multiple, even more than 2 events. So let's give an example. Let's say you roll a die twice, and we want to know the probability of getting 2 6s. So you roll a die, you need to get a 6, you pick it up, you roll it again, you need to get another 6. First of all, we have to answer, are those two events dependent or independent? The answer in this case is independent. What we get on the first die doesn't have any bearing on what we get on the second. So the first event is A, roll a 6. The second event, B, happens to be the same thing, roll a 6. The probability that we roll a 6, the probability of A is 1/6. The probability of B that we roll a 6 is just the same thing, 1/6. When we multiply those two together, we get 1/36. That would be the probability that we would roll back-to-back 6s. So when two events are independent, you probably already, from previous videos and previous work on the homework, know how to deal with those probabilities. What we need to spend a little bit more time on are probabilities when events are dependent on each other. So I'm going to give you one example problem that hopefully will guide your understanding of this, and then you can take a look at some of the homework problems that are structured similarly to these. Here's the setup. A box contains cards numbered 1, 2, 3, 4, 5, and 6. So there are 6 different cards in this box. A card is drawn and not returned to the box. Now that phrase, not returned to the box, or phrases similar like that, without replacement, are significant because normally that should trigger in your mind the idea that, okay, by not returning something to the box or by not putting something back, these two events have now become dependent. If we drew a card and then we returned it to the box and then drew another card, in that case, the two events would be independent, have no bearing on one another. But when we don't return a card to the box and then we draw another card, then suddenly those two events become dependent. So back to the example. Card is drawn and not returned to the box, and then a second card is drawn. What is the probability of drawing 2 even numbers? Okay, so what we need to do is we need to figure out the probability of the first even, and then we need to figure out the probability of the second even. And when we figure those two out, we're going to multiply those two together to figure out our overall probability. But different from independent events, these two probabilities are going to be different from one another. This probability is going to affect this second one. Let me explain why that is. The probability on the first draw that we draw an even number is pretty simple. There's 6 total cards. The 2, the 4, and the 6 are even. So 3 out of 6 chance, or 1/2 probability, 50% probability that we will draw an even number on the first draw. When we get to our second draw, since the card is not returned to the box, we no longer have 6 cards in the box. We now have 5 cards in the box to choose from. Also, we must assume that the first draw was even. If the first draw was even, the number of even cards left in the box must be 2. So there's 2 cards left that are even out of a total of 5 cards in the box. The probability that the second draw is even is 2, that's our favorable outcomes, divided by 5, that's our total outcomes. So the probability of a second even is 2 out of 5. When we do this multiplication, we end up with 2 over 10, or to simplify, 1/5. That's the probability that we would draw 2 even cards. So the takeaway here, the thing to practice on your homework, is to note that when events are dependent, what happens in the first event will have an effect on the probability of the second event, and it's up to you to figure out what that effect is and then to change your second probability to match your situation.